Okay, what's up? Let's begin. I'm back after being away for 6 days, including the weekend. Been a little bit sick, my son as well, so had to rest. But feels good to be back. Let's just jump right into it. It's still the reflection solution we're fighting. We started implementing it last week, if I remember correctly. We have one tutorial, and then we have one other solution that is presented that we can rely on. None of them implemented in Unity though, but so I haven't looked at this code for close to 6 days, but if I remember correctly, we went a little bit off script. And found some pretty weird results, and I just want to make sure that I haven't misunderstood something very basic here with these mistakes. So I'm just gonna bring up GIMP, get myself familiarized with this problem again. So we have the screen. We want to render a point within the screen, or we want to reflect. For that pixel, we want to colorize it based on reflection. So we send a ray out from the camera, so into the screen or into the scene. And we pretty much just do it like this. We calculate the position of this frame we're about to render. Then we calculate the direction from the camera, and then we have the direction of the ray from the screen into the scene. We then reflect it on this point, the normal of this point. And that gives us, or actually this point is the start position of the ray, and then the reflection vertex direction together with this one makes it possible to calculate the end point of the ray. But to keep it simple, we calculate a reflection ray, and then we want to step through that ray. But we don't want to step through it in the scene, because you might have rays that are parallel to the view. So that means that you will just be stepping over and over in the same pixel. Instead, we want to step through it in screen space. And for each step in screen space, we want to calculate the scene position, we want to check the depth there, and we want to see if the depth is within a threshold of the depth in the scene texture. If so, we have an intersection, and that is something we should reflect. That's pretty much it. That will give us good results, or acceptable results. Then you can improve it a little bit by adding a second iteration. But we haven't really gotten the first one to fully work just yet, because as I've understood it by reading this tutorial and the other solution we have, what they do when they walk through the ray in screen space, so let's say that in screen space we have a ray that goes like this. This is our reflection ray. In the shader setting, they usually, if I've understood this correctly, they say how long in pixels or screen UVs should each step of this ray be. And then they just step that distance. They also do some calculation which is the primary direction, Y or X, but that's pretty much it. And then they step, 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 and when they're outside, they quit the first part of the algorithm. If they haven't found anything here, this ray is probably just gonna fly into the distance, probably reflect the skybox. Yo, what's up, Cold Bones? So that means that the number of steps for a ray is a value 100% based on the length of the ray, right? So that means that a ray that goes like this and a ray that goes like this, they will have the same march distance. So for this one we would only do 2 samples, for this one we would do a lot more. And that is acceptable, I guess. I was just thinking, maybe this is the best way to do it. I was wondering if you would like to have varying ray march distance based on how long the ray is. And that's where we got stuck, or I got stuck in the middle of last week. So last stream. So basically what I wanted to do is, if we have this ray and we have this ray, I want to calculate this point. So the point where the ray goes out of bounds, i.e. outside the screen. So then we have the start point and the end point in screen. We have the start point and end point for this one. And then we notice here that this one is way longer than this one. So for this one, I would like to make smaller steps, but not smaller than one, the delta size of, or smaller than a pixel size. So for this one, we might end up with moving pixel per pixel. For this one, we will do a little bit more steps. But I wonder if, in the end, this might not give better result. This is pretty much on the opposite side of the spectra, so that might not be a good. But if we take this ray and we take this ray, with this solution we might get 2 more steps here. Fuck, maybe that is a good way to do it. It's the easiest way to do it as well, because what you do then is you just step, 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 and for each step you check, are we out of bounds? No. Okay, step. Are we out of bounds? No. Okay, step. Maybe. Colbones, what the concept you're figuring out? What are these rays for? We're doing screen space reflection. So we pretty much calculate a reflection ray, and then we march along that ray and see if we intersect with something. If so, we reflect it. Pretty much. Yeah, maybe we should just walk. We have a pretty defined smallest step, and we check each iteration. Maybe it's, let's just make that work first, and then we can see if we can improve the performance or some other improvements. Yo, what's up, Calvino? Thank you. Feels good to be back. So the problem we want to solve then is I wonder if we want to step it. So we define in the shader properties, we define step size in UV space. We have to keep in mind that you usually work with screens that are not square but rectangle, so usually 16:9, but when we work in UV space we have normalized it to a square, so when we figure out which is the dominant direction, Y or X, we need to keep that in mind. Or do we? Okay. So now I've refreshed my memory of this, and this is the current result we have. We have some banding going on here. It's rough. We're doing a lot of steps, if I remember correctly, as well. Max steps to 16. Oh yeah, this one. Yeah, there we go. Yeah, okay. Okay, I think we're gonna add one of these. Let's see. Okay, we want this to work on many devices as well, so we have to decide upon. We would probably like to work in. I enjoy working in normalized coordinates the most, so instead of working in absolute screen space resolution, I like to work, so instead of working between let's say 0 1920 1080, I like to work between 0 and 1. But if we define our step size or step length in normalized coordinates, then we might have a case where we step smaller than a pixel, so we need to double check that. And we also have the case where, so a step of 0.1 in the X direction is usually a bigger step than a 0.1 in the Y direction. Calvino, help me step length, I'm stuck. And that one flies over my head. So we should probably do it like this. We should base... Yeah, let's do it like this. Maybe that's for the better. Yeah, maybe. We're gonna do... We're gonna do it like this, I think. Step length. Can you write descriptions on properties? That would be very nice. Shader properties. I think you could. Should be able to. Yes. I don't want to write. I don't want to do this. Oh well, let's put it here. Step length. Actually, let's do it like this. Step length. In, or... fuck me. I think we want to have it as... Okay, so if step length is 1, then we're gonna walk 1 pixel. If step length is 2, we walk 2 pixels. But it's not as straightforward as that. Like, okay, if it's 1, we move 1 pixel in the primary direction. If it's 2, we move 2 pixels in the primary direction. Is step length in pix. Step length for primary direction. I don't even know if I'm gonna be able to understand this in a day, but yeah, let's see. Integer. And we want to do 1 here as default. Yeah, I want to keep max steps here because we definitely want this one to exit if I implement something wrong here. But let's see. We have ray start point SS, ray end point SS. We have screen params, pixel delta, so 1 divided by... Okay, great. So what we can do then is... we want to create the step vector. So step is equal to can we do this in a nice way? So we want to figure out, is X or Y the biggest? The biggest one is going to be decisive in how much we move. Yeah, I think we do it like... a simple if is probably best. Let's do it like this. Delta to step is equal to if delta dot x is bigger than delta dot y, but we want to do it like so if x is bigger than y, then we want step to be equal to we need to figure out the ratio here. And do we need to take pixel delta into account? We can probably do it like this. Okay, so if x is bigger, then we move 1 pixel in x and whatever the ratio is for this one. And when we have that calculated, we multiply it with step length. So yeah, if x is bigger, we want to move 1 pixel in the x direction, and that is this. So for this screen, this is 1 divided by 2560. And we want to get the but yeah, we might want to do sine delta x times this one. Okay, so now we move either 1 pixel to the left or 1 pixel to the right, and then we want to get the ratio with delta y correct. So first of all, if we're working in 0 to 1, 0 to 1, we would just be able to do delta dot y divided by delta dot x, right? So if this is but does this take ratio into account? I'm not sure. It should. Let's do some quick calculations. So if we move in screen space, let's do it simple. So we have 1920. Fuck, let's do it in Notepad. So if we have 1920 times 1080, and we get a direction vector that is, let's say 0.1, 0.02. In this case, so we do abs delta, we get 0.1, 0.02, so x is bigger. And then we take sine, which is positive, and then we take pixel delta x. Let's see. It's 1 divided by... If I guess there's two small values, we can go bigger. Hovseder, is it a fellow Swede I'm hearing? Hell yeah, it is. Let's go, oops, 0.2, 0.4, 19, or actually, never mind, that's not the size that decides this. So what did we have? 0.00052, right? And okay, so that's what we get here. We multiply it by sine. So this is our direction in the x axis. What are we working on? Broadly, we're working on like a monster collection type of game, much like Viva Pinata, Chow Garden, Tamagotchi. A little bit more specifically, we're working on a terraforming system, so to be able to add rivers, mountains, whatever, in a garden. And very, very specifically, today we're implementing screen space reflection, so we can use it for our water and other interesting stuff. Okay, so now the question is this one. I just need to figure out, so if we would have just transferred these two pixel values initially, it would have been 0.1 times 1920. I could have figured that one out. And 0.02 times 21.6. So this is the step we would have done if we would have just taken this direction and marched along it. So this is the ratio we want to keep. This is very important. Okay, so this is 1 pixel in x direction. We want to keep the ratio. So right now I do delta y divided by delta x. So that would be 0.02 divided by 0.1. 0.2. Yes. So now the question is, do we want to multiply this with the vertical delta in pixels, or do we want to multiply it with this one? I think we want to do it it's extremely important that we keep the ratio. So 0.0052 times 1920, roughly 1. Fuck, it's this one we want to do it, right? So 0.2 times 0.00052, 0.00014, 21.6 divided by 192, 1125. Oh yeah. So I wonder if we want to multiply. If we want to multiply this one with, oh fuck, what did we have here? We had 0.2. So if we take this times 0.0009259, so 0. Fuck am I missing? But. Number 6192. Maybe. Or is it this ratio we care about more? If so, yo, what's up, UBDev? Yeah, always the but. Always. Now fuck it, we should be able to rely on this ratio. So we have a ratio of 0.2 there, so x direction is 0.2 of the y direction, so we should be able to do 0.2 times 0.00052. Right. Let's do it. So what did we have? So we take this and then we want to multiply it with this though, but do we want to do it with sine? I think we can do it like this. Like that, right? So it's pretty much, if this one is bigger, we take that one and we set it to 1 pixel length, and we keep the ratio of this one like this. If it's the other way around, we pretty much just do this. Never mind. If it's the other way around, we do it. We flip these two first of all, like this, and we do delta x divided by delta y times pixel delta y. Like this, I think. Probably missing something. And then finally we want to do step multiplied equals to step length. But step length, step multiplier. Let's call it step length for now. So this is pretty much just, we calculate or we figure out which is the primary direction. we take the primary direction and we transform it to 1 pixel in length, and then we take the other coordinate and just multiply it so that the ratio still stands. And this is how long we should step. Let's keep step count here, step count 1. T, this is not how we want to do it anymore. We want to do it like, so ray current point SS. Instead we're gonna rely on fuck, but I would like a T here, definitely, because we use it here. Would like to skip inverse lerp to figure out the T, so can we do ray start point, ray length in, I want to switch this one to ray length in, ray length in view space. And then I think we want to do a ray length in screen space is equal to, can we do distance between ray start point, ray end point. But actually I only care about X and Y. So then we have the ray length, and for step count here we do step count 1. We do T is equal to step count times step, but this is XY. Then we calculate distance again here. That might be a little bit too many calculations for this for loop. Because what we would do here then is we would do step count times multiplied with step, then we would take the distance between this one and the start point divided by the max distance. Maybe this is not too costly, but if we do this, let's see here. Ray current point in screen space is pretty much going to be equal to ray start point in screen space plus step count times step. That's the current point in screen space, and here we just do inverse lerp. Ray start point SS dot XY not current point, ray start point SS dot XY. this, so we do an inverse lerp here. Is that too much? We might want to store this one as well, so we do float t is equal to so our current point is our start point xy plus step count times step. We move by default 1 pixel in the primary direction. Then we do an inverse lerp here. So how far along the line are we? Then we calculate the depth at that point in view space, ray depth. VS. Then we sample the scene depth. We don't want to do this check right now. Depth difference, and if this depth difference is between 0 and thickness, then we return 1. Otherwise, ray previous miss point, ray current point SS. Yeah, this one should keep us from crashing. So I think I dare do this. Fuck yeah. Oh, that looks fucking beautiful. A little bit worried about the pillow here. And what performance do we have? We have shit performance as well. Shit result and shit performance. That's rough. And I also still have this problem here, but I think we can fix it. This one, we're gonna add a extra check. We're gonna do this. While step count is less than max steps, and ray previous miss point ss.x it's gonna be multiple checks here, which I don't really like. We're gonna have to check, is it bigger than 0, is it less than 1, or bigger or equal to 0, or is it less than 0 or bigger than 1, or if it's, yeah, and we're gonna have to check that for both x and y. I wonder if we want to do the check down here just to make it look cleaner, more clearer. And we also, I've been wondering how to do this. So for instance, if we have a ray that flies away, it doesn't hit anything and it goes straight into the sky basically. What we want to reflect then is the skybox, right? So we're gonna have to call a function here where we get a skybox value. Right now we have a procedural skybox, so we're gonna have to add, that's gonna add a lot of extra calculations. We're probably gonna end up with the procedural skybox in the later down the road as well. So that is definitely gonna add a lot of calculations. Unless when we have our custom skybox, we might do it as a render feature that renders to a cube map or something. I don't know what would be the best approach performance wise. probably just calculating for the pixels that needs it, but whatever. That's in the future, so let's try not worry about that. But what we can do here is bool out of bounds or in bounds. In bounds. So at the end here, I think we can do it here. We do in bounds is equal to ray current point ss.x is zero. Do I want to do bigger or equal to, or do I want not? Let's see. If it's less than 0 or ray current point ss.x is bigger than 1, or y is less than 0 or is bigger than 1, if this one is true, or this one is true, or this one is true, or this one is true, we're out of bounds. So let's do this. So if all of these are false, we're still in bounds, and we continue. Okay. Good. Now we don't get this artifact anymore, so that's good. This one worries me a bit as well. So for this one, I reckon we have rays that reflects here, flies here. It never intersects with the bed and gets outside of the screen. But it doesn't look too good. We want to ray max distance. Why don't we get more here? Oh, do we need to? Oh, fuck. We're talking about a lot of steps for pretty bad result. But if we do max steps 200, we do step length 2, do we get banding? Yes, we do. 3, 4, 5, 6, 5. But if we do thickness 1, 2, 1, oops, 1, 2, 3, 2, this one bothers me as well. What artifacts are we running with here as well? What the hell is that? But that's not related to this, I don't think. It still bothers me though. Oh, is that actually... Oh, well. We should be getting white as well here, maybe. Why are we getting... I'm bothered by quite a lot of things here. I'm just trying to visualize, why wouldn't we get a hit for a ray here? It should be going through the character. We should get... We have this one as well. If this one goes up here and up here, does it actually fly through the bed? Ah, yeah, okay. Yeah, we only have these depth values, so yeah, this depth value, yeah, it's... We don't intersect with this one. Probably don't intersect with this one. Is this the same thing with the hand? Yeah, probably. Can we minimize this? Very interested in what the hell is going on here as well. What depth value do we get here that intersects with the ray? Is it because we're intersecting with the ground? Okay, so the smaller the step length amplifies this artifact. Why? Show depth scene 1. Linear eye depth, yes. Okay, we want to do... They are the same, so we don't have a mismatch between those depths. That's good. This one returns 1 if depth difference is bigger than 0 and less than thickness. Depth difference is scene depth vs minus ray depth vs. We do negative, negative. Fuck, should we just do There's no difference. But do we not care if... Do we want to do abs here? We would care if this one is smaller than this one with a tiny bit. I think we want to do an abs here. Don't think that will help with this one, however, but let's see. We do get a little bit of a better result here, don't we? I think we do. I think we do. But this problem is still here. Very weird. .015 in said thickness. So this is pretty much the value we compare. If the difference is less than this, then we have an intersection. So we're talking about 1.5 centimeters. If the difference is 1.5 centimeters, or if it's less than that, we call it an intersection. I think that's a pretty good value. The angle looks to be in such a way that this should not be an intersection with this, right? But is that the case? Camera node 180. Yeah, it's this shit. Hmm. Could it be? Could it be that the first step is so small that we get an intersection with the ground underneath? I'm pretty sure. Ooh. Yeah, maybe we want a... Yeah, I'm pretty sure that's the case. So 0.01, 2, yeah. Yes. Said thickness. This, we could solve this by having a dynamic said thickness. So, which is actually a very good idea, I think. Extremely good idea. So the further along the ray we have walked, the greater the said thickness becomes. So if we have a ray that flies extremely far into the scene, like, then we definitely want said thickness to be bigger. This should probably be... This is probably how we want to do it. Stride jitter. Yeah, that would solve this problem, I think. But the question is, why are we not getting the same result here and here? But if we do 0.1, this one disturbs me. Okay, this doesn't make any sense if that's the only problem we're having here. Or does it? What's going on here? But that could very much just be, if we do max steps 300. Oops. Now something is fucked with the perspective. Ray max distance though. 10. But then again, in this case we get a ray. Ooh, do we have a problem in the negative direction? We have a problem here. We don't have the similar... Ah, we have it here. Yo, what's up, Lemon Cat? What's the game about and how's progress going? Progress is slow, but it's going in the right direction. It's about cultivating a plot of land, making it habitable for some creatures, eventually. Do we have a problem with this calculation right here? If I were to blame anything, it would probably be this. Because I think going down to 1 here bothers me, but yeah, we're moving way smaller steps and we still have a max steps of 100. Let's go 300. Then we get back to this one, yeah. Because that's actually different and nothing like I've heard before. Keep it up. Thank you, appreciate it. It's actually heavily inspired by a game called Viva Pinata, which is a very good game. I recommend it. It's old now though, but... Okay, so this makes sense. But... Fuck, does this make sense? I guess it does, but I don't think... From this point, following the screen space ray up to about here, could it really be... Yeah, it could very... Yeah, it's probably around 142 pixels, that's for sure. What do we have? 1440. Could be. But if we get this artifact thanks to the said thickness, so we do one... Ooh! Nah, we don't do the ray start position. But if this artifact is based on the fact that we do reflect on the surface, and for the first iteration the depth is within the bounds, why isn't it the case for this one as well? Just found... That's very weird. Very weird. And this, does this make any sense? So 103 2 3 2. Nah. Or this is also very weird. But and then we flip here. This looks to be a projection error, right? Fuck that, that's weird. So what could be the cause for that? I'm screwing myself over by doing this in linear eye depth. I want to double check one thing. If we do plane, can we bring this up? 1.01, and if we do 0.015, that's when we get this one. If we bring this one up, yeah, then we don't get it. So it's probably the culprit. Five, 4, 3, 2, 1. But we still have this issue. So I'm talking about this one. It's only... So we don't get it... Oh, come on. We get it here. We get something weird here as well. But we don't get it here. Yeah, it's the same with this one, so it's probably negative x or negative y. Did I screw something up? And I'm talking about here. Sine. We calculate delta here. Ray endpoint SS minus ray start point SS. Pixel delta y, pixel delta x. Pixel delta is always positive. Could it be... No, we should... Ooh. Could it be this one? Yeah, if this one is negative and this one is negative, this one becomes positive. We have the same issue here. This one is... Okay, so if we have negative delta x and negative delta y, we get a positive direction here. That's bad. This one has the correct sign. This one has the correct sign. This one does not. So are we gonna have to do sine abs and then sine? Yeah, so it does make sense, right? This is negative, this is negative. This becomes negative, but this becomes positive. So we can do abs sine delta dot y abs Yo, what's up, Gustas? This would result in a correct sign, right? Negative x, negative y. First one becomes negative x. Second one becomes negative y. Let's see. Do we have... Yeah, now we don't have those issues anymore. Could this actually have been one of the reasons for this one as well? Could very well be, actually. 2, 5, 2, 3, 4, 5. Ah, fuck. We have this one at 1.005. We still have this one here, but this one I think... Yeah, I'm pretty sure we get a 2 similar depth value here. I'm pretty sure. So for instance, if we would lower this one, we get rid of those, but we also lose. Actually, I'm gonna do this as well. Let's keep it. 10. Fucking hate the banding we get from this one though. 1, 5. Pretty sure. Let's try and do this. Thickness, we're gonna try thickness bounds or thickness based on distance. And then we do we have float T here, so we do ray depth vs, scene depth vs. And then we do thresh or intersection threshold is equal to lerp x, y, t. So if we're close to the start of the ray, we use this, and the further along the ray we are, the more towards this one we use, based on linear interpolation and the t. And then we do intersection threshold. That's the one we want to use. If we do abs here, we don't need to do this. It's always going to be positive. And then we do intersection threshold. We'll do 1 and 1. 0.01, 0.5, and then 1 here, 0.01, 2, 2, 3, 4, 5, 6, 7. We can go pretty high here, 1. Yeah, we get that intersection there. Yeah, we don't want to go 1. Yo, what's up, Basil? 1 might be a bit too much, but 0.5. But then again, yeah, this will lead to a whole set of other artifacts. I find it extremely weird that what we're seeing here, it's basically the planks under the mattress. That's weird, isn't it? Ah, you see a tiny bit of them here. Wow. So I just found your channel. I'm already invested. Oh, appreciate it. Thank you. I've been learning Unity, but I'm still pretty bad. Don't worry. We were all bad at one point. Good luck with the progress, though. Looks pretty good, but did we get a performance loss or gain? I don't know. Let's do plane and do 0.1 is a bit too much maybe, but that's 0.1 at the end of the ray, so that might be okay. Step length 2, 3, 4. Okay, now we have pretty good performance, but we have this banding issue, which I fucking hate. If we change this one, we still have the banding issue, right? Yo, what's up, DevSpios? Thank you for the raid, appreciate it. And welcome to all the new viewers. U2 DevSpice U2. So I don't get the new version input system at all. I didn't update my version for like 2 years. Oh yeah, I also had some... I found the learning curve for the new input system to be way steeper, but the new input system is way better. It's way more flexible. So I definitely recommend keep trying with the new input system. I guess it depends. If you're just... The more input devices your game supports, the better. And for that, the new input system is better, I would say. But no, by the way, thank you for the follow, appreciate it. Okay, so what the hell do we do about this banding? Because that sucks. So if we do 0.1 here, might still be a bit too much, honestly, but 6, 5, or 1 sec. 1 sec. When we increase the thickness based on distance, we probably want to increase the step length as well, don't we? Wouldn't it be nice? So at the start of the array we do a lot of samples, at the end of the array we do few samples with bigger... maybe. Fucking hate this banding though. I wonder if we do this, we return 1 instead, so we can see the... this is acceptable though. This is not. Oh. This is kind of rough as well, honestly. The best result is always going to be 1, 0, 0, 0, 1, 5. But the performance takes a big hit. Yo, what's up, also? Welcome to the Twitch as well. Appreciate the follow. I wonder what if we want to do this. If this is the array and we step, and then for this one we find a hit, an intersection. I know that one solution takes, if we find an intersection here, we take this point and we calculate where along this one the intersection is the smallest, or the difference is the smallest. But I wonder if, I think it's this one and this one, but, or maybe this one and this one. And then we'd step through here. just want to see how this looks if we do return sample texture 2D scene texture ray current point SSXY. Pretty rough. I mean, if we're just gonna do water, so water moves a lot, we get a lot of noise on the reflections. Then this is pretty much exactly the point you could get away with, I reckon, but still. Performance is okay. Yeah, so here we can see that it's the ground underneath we actually intersect with, or that we reflect. Then we have this, there's nothing we can do about this, I don't think. Yeah, so with a step size of 1 we have pretty good result. As good as we can get in screen space, I guess. But the performance tanks. Still have this issue. And yeah, we can only reflect what we see. That's why we get this as well. So it's our job to work around this and just try to make it less apparent. 2, 1, 2. Okay. And honestly, these line artifacts we get here, I don't know where we're getting those from. Yeah, slowly moving forward, Derek. Yeah. I think we can move. I think we can. We just want to reduce the artifacts we get at lower resolutions here. Fuck, I'm worried as hell about this banding here. Seems to be... Six pixels. We should... Is this... the line artifacts we see here? Is it because of... It's the skybox, right? We're getting... Is it because of... Is it clamp wrap or something like that? Let's see. I just need to make sure that it's the skybox. Skybox prettier. Oops, that's not what I want to change. Yeah, it is. Why? Yeah, we want to wrap it, but or not wrap it, but clamp it. That's one case at least. But still. Oh, yes. So we do. Would probably like to do this. Would probably like to do this check before we do these calculations. Yes, because we might actually do this with a texture that is out of bounds, or a texture coordinate that is out of bounds. So for now we could probably just do interesting. But we still have this issue up here. Okay. Oh. We want to remove this one here as well, right? Yeah, so now we no longer have this issue. If we do a steep angle like this, we still get this issue though. Interesting. We have this as well, but that's... the ground underneath bleeds into this as well. Probably want to do a point sample, but we can look into this soon. The first problem is these. I also want to double check one thing real quick. Could we blur this by doing LOD 2, 3? And we could. And that's gonna help a little bit. That's rough. We only blur the colors, we don't blur the edges, but that's okay. Okay, but this issue. So if we hit a ray here. Oh, maybe. Let's see. We hit a ray here. We have a max distance of 10. So this ray probably flies this into the distance and ends up somewhere around here. And that's the end point of the ray. Step count, we haven't moved enough steps, so we're gonna do this a lot of times. And finally, I don't get why we're returning blue though. Show depth scene 1. Let's take this plane and yeah, we have a depth of 1 here. Or we're extremely... Oh, no, way. We have a depth of clip plane far, I think. That should still not result... But we can see that it's white, so we definitely get into this section. So depth difference is definitely less than intersection threshold. And when we're this far away, we're probably, so we're at max distance, we have this thickness. So this is at 0.05. Scene depth VS minus ray depth VS. This should still not... This should be way bigger than this one. Unless something very weird happens. So scene depth view space, it's... At this point we have a depth of 1,000. This one is not even close to 1,000, I don't think. Definitely not. So what's up? This one is not close to this one under the assumption that this one and this one are calculated correctly. Ray current, ooh. Okay, so what happens? Fuck. We just keep on adding in screen space. We're pretty much working with this ray as if it was infinite, so we keep walking in the distance we were, probably end up here. Because we do this every iteration here. We do this max steps of iterations. We do it 250 times. So we probably end up $250 times. Yeah, we probably end up at a point. We end up with a point where this is true, obviously, but it's true because this one, it just grows and grows and grows. No, not this one, but this one. T becomes way bigger than. So I wonder if we just do this, well, we get rid of the. This is definitely not how we want to solve it, but will it get rid of the artifacts? Yeah, it will. Okay. So could I do this as well if t is bigger than 1, return 0. And let's see here, I want to try and do. We don't want to do bilinear filtering here. We want to do a point sample, but I just have to check one thing. Yeah. I don't think I want to do this. We want to wait with this. But what I'm getting at is, let's see here, scene texture, create scene texture. Yeah. Or actually, let's see. Yeah. We don't want to screw with this one. So when we generate this scene texture, we don't want to remove the bilinear. Like we want to be able to sample this one with bilinear filtering. But I want to add the option in the screen reflection here. that when we define this scene texture here, we want to use a sampler that does point filtering, and we have done it once before. I don't remember. Transparent blur box. I don't remember where I did it. So let's do a Google search again. We want to do Unity HLSL sample texture point. Yeah, we have to rely on this, and then we sampler state, and then it was something with the naming. So if we name the sampler point, yeah, we probably want clamp as well. So if we name it main takes point clamp sampler, let's try it. So this is the kind of result we have now. So if we do, okay, can I do texture 2D and sampler state scene texture point clamp sampler. Ah, fuck. Wrong shader. So let's copy this, change it back. I wonder if we can use this one still. I'm not sure. Well, we can. But this actually doesn't get rid of everything. Okay, interesting. Interesting. It's definitely the ground we're seeing here, I think. Let's just double check. Yeah, it is. And it's independent of step length as well as thickness. Oh, we haven't haven't even taken outlines into account, but I don't think outlines will save us here. So we get a sample here, and we get a lot of the ground color. Is it because of the alpha of this one? Now we don't have any anti-aliasing. Oh, is it actually because... What? Let's do... show depth start. That's not what I want to see. Oh, that's the wrong one. And I'm doing this under the assumption that this point clamp sampler does its job, and yes, we want 0 here. Fuck yeah. Okay, so if we do point sampling, we're okay. I just want to try... I want to change this back to not point. Okay, we do bilinear. Yeah, then we get this. But if we have point, we don't get it. Okay, that's good. Slowly but surely we're getting at... or we're getting to acceptable screen space reflections, I would say. We still get, like... I'm having a hard time differentiating or identifying problems. I would... yeah, I'm having a hard time identifying and grouping problems into... So you have problems that are improvable or solvable even though you have screen space reflections. But then you have some problems that are unsolvable if you rely on screen space reflections. So for instance, this right here is like, this one reflects to whatever is here, but we don't have that information, so we can't really solve this. And I think this problem right here is relatable, or even like this one. But this one is, yeah, we can solve it by going down here. One could think that for this problem we could if we go outside here, we compare with the depth we have here, which could work at some points. Maybe you could do some hacks to make it look better. But like, it's hard differentiating where there's pretty much nothing we can do about this. As opposed to there's something small we can do to solve this issue. This banding I definitely want to get rid of, but we're gonna have to add a second iteration, which I'm not looking forward to doing. Pretty much, I guess this is the best possible result we can get, if you don't count this artifact here. And then we can max I'm interested in why we're losing this one here. We're doing 500 steps. We're doing 1 pixel at a time. So we should be seeing something here. Max steps. Unless we return. So red we move outside of screen. Green we move outside screen line, but here we still get pure black, so we never find an intersection for this point, which that's weird. But if we do why does it just stop here? Can't imagine maybe how far is this to here? It's half the screen basically. It's around 700 steps, so that might be true. Huh. Okay, that's why. But it's very interesting. Look here. I want to look into one thing here. So for instance, if we have this ray, and it goes behind this object, we don't get an intersection, but we do get something. Like if we were to fake hitting the backside of this one, could we manage to do that without destroying too much? So if we walk along the ray, if we don't find any intersection, can we take the best intersection, so the intersection with the least amount of error yet, and do something with that one? But for these points, we're probably going to get what is right underneath it. Now we're still in front. Maybe we just care about backside. Yeah, we do. So scene depth. If scene depth is big, yeah, we don't care about if it's smaller, so we definitely want to do depth difference is bigger than or equal to . But we do get way worse result, right? Oh, that's not what I want to do. A little bit, but that could very much be, let's do 300 to 3. Okay, we have this one. Scene depth in view space is smaller than this one, so this should result in a negative value. So this should not be true. Right, but yeah, this should definitely be smaller. One sec. Yeah, this one is bigger than this one. Yeah, do we want to do? Let's see, I wanna I wanna figure out when a ray is behind something. So ray depth should be bigger. Yeah, this is way better result, right? We don't get this error anymore. We can go 5. We can go pretty crazy here. Fucking 10. We can go crazy here as well. 0.5. Oh, this is way better. But now we have banding issues like this, but that's okay. Like this artifact, it almost looks like it is a reflection on water already. But yeah, and then we have this banding artifact, that sucks. But if we do a second pass, we're gonna get rid of it. What do we have? 200 FPS. These banding artifacts though, what the .5. Nah, we definitely want to do ray max distance 10. Do we care about this one that much? Does it? Yeah. Step length. We can do a lot of hacks here to improve it, but I'm wondering, like, step length. I think I want to increase that one the further away from the camera we are. That would mean more jagged result here. So if we do this here, so 2 or maybe even 1, 2, 3. 3 it's okay. But then further away we do 6. It's gonna be jagged as hell. But while we improve that, if we improve this one, we could probably get away with 0.1 far away. So it's about syncing this one and this one. You could get away with a fucking shit ton when we're far away. But you can see here that it affects this. Is it this one? Yeah, it is. What are we seeing here? I'm very interested in this result we're seeing here. This one specifically. What if? We keep track of the closest point to an intersection we have. So if we don't find an intersection, then we take the closest one, the closest point to an intersection. We can probably add another iteration there to improve it even further later on. But so we could probably do this to improve it a bit. Let's see. Yeah, pretty much this. So we have a ray, we march this length quite a lot. We save the point where we're closest to a intersection. It's probably this one. So this is the first iteration. The second iteration, we take this point, we take the previous point and the next point, and then we do sampling between here, but we do it with way smaller. We could even do it like we take this point, we check if this one or this one is a closer intersection, then we pick that one. If it's this one, we check if this one or this one is a closer intersection, and so on. But that's not the issue I want to solve now. I think we can do... So we go through the ray marching as we do. We store the point where we're closest to an intersection. So if we don't intersect with anything, we have that point. So at the second iteration, or it's not really an iteration, but if we don't intersect with anything, we take this point, we have this point, and then we measure how close was this one to intersect with something. And based on this, so if this is the object it's going to intersect with, based on this distance, we calculate how much of this color should it have. So if it's very close, we just color it in this color. If it's very far away, we color it a little bit with this color. And then we can do some extra magic here. We can do we can fake lighting as well. So if this is a normal that doesn't point to light, we make this darker as well. So in this case, this one intersects with this one. Here we're gonna have normal, but let's take this point. This is extremely close to intersecting with this point, but it doesn't. So later on in these secondary calculations, we check how close it is. If it's very close, we color this one white, and the further away it is, the more we color it like the ground beneath it, or something like that. I don't know. Just to fill in the gaps in a hackish way. Like, then again, this reflection doesn't have to be perfect, because we're mostly gonna use it for water, and we're gonna distort the water a lot. And so we're only gonna reflect on water surfaces that are aligned with camera view and light view and a lot of things. So it's gonna be, we can get away with a lot here. We could probably get away with this as well. Honestly, it's not too bad. But yeah, I just wanna explore some of these hackish way we can make this look better. Just give me a sec. Okay. So first of all, I want to put it, let's do 0.01. Now let's go with 0.1. Like, I hate the fact that we have a button in the way here though, but that we're seeing the hair. Yeah, I don't know about that. But anyway, let's find an angle where we have a problem I want to solve. So maybe this one. So here I would like to see blue fill, same here. So we're gonna do fuck, let's clean this one up first. We're getting closer to an acceptable result, so we don't need overshoot. That's an old solution. Let's do, I think I just want to store this one in a file so far. Okay, let's do something like this. Previous depth, current depth. We don't use these right now. We don't use. Yeah, we don't use these two right now. Previous misspot, we don't use this one. We just set it. So let's do float. Smallest depth difference, and then I would like to have float.max or something, maybe. That's not the one I want. Don't we have anything like this defined in HLSL? The fuck? Actually, we can probably do this. Artifact reduction variable. Fill. Fill range. Smallest depth difference. Let's just define it like this for now. Float 2. And then we do, if we find something like this, we definitely want to return else. Yeah, we can put it in else. If depth difference is less than smallest depth difference. Smallest depth difference is equal to depth difference, and we also want to store is equal to ray current point SS. Okay, so if we never find an intersection, we do this. Return float 4 fill color is equal to lerp between float t fill is equal to, let's start with this one, inverse lerp something fill range dot x fill range dot y smallest depth difference. So the closer we are to this one, or yeah, the closer to 0 we are here, the more towards this we're gonna get. Or the closer we are to this one, the closer to 0 we're gonna be. The closer we to this one, the closer to 1 we're gonna be. So the bigger this one is, the bigger this one is gonna be. This one is between 0 and 1. So that means that the original color, we want the original color to be towards 1, right? In fact, I want to saturate this one as well. So when we do fill color, we want to lerp between sample texture 2D, scene texture point clamp sampler, smallest different point SS dot XY. So lerp between this one. Here I'm just going to return black for now. And we want to do it with tfill. So if this one is very small, we're getting closer to 0, so we're getting closer to this one. If this one is very big, or yeah. We want this one to be small, this one to be big. That's going to give us 0 here if we're at this one or smaller. So we get this color. Otherwise, this, yeah. Yeah, we want to return this one as well. Let's see here, fill range 0, 0. So both of these are 0 right now. We're always going to get 0 here, right? It's always scene texture. We actually returned red here. If this is true, we don't need these anymore, so let's just do break. Okay. So it doesn't matter how much bigger we make this one. If we make this bigger, it doesn't matter either. Okay, so where did I go wrong? Yo, what's up, Game Train Studios? Thank you for the raid, appreciate it. Hope you had a wonderful stream. Thank you, you too. Yo, what's up, Sander? Over on this stream we're fighting with screen space reflection, but I think we've done wonderful progress today. We're just trying to minimize the usual artifacts you get by going very much off script, but yeah. I get the feeling that this one is never... Oh... We probably also want to check depth difference bigger than or equal to 0. Yes, that's more like it. So we get a pretty good fill here, I would say. I want to see if we bring this one down, we remove this fill. Ooh. Ooh. So instead of having this, we can get to... it's rough. But I like what I'm seeing here. For this one, I think it works pretty good. We haven't taken the normal into account just yet. For this one, it's a little bit rougher. And this is just a first try with this. That's pretty good. That's pretty good. But I wonder... this one. There we go. I'm so stoked to see this on the water. Yes, same here. I think it's gonna improve it tremendously. Okay, so we have a ray here, reflecting up here behind the hand. Yeah. I don't like it for this, but I do like it for this. I fucking hate it here. Maybe less is more in this case, so 0.1, I don't know. This is probably better. Yeah, we actually get a feel like ray thickness based on distance. Intersection threshold thickness. What do we do? We do T here. Yeah, that's probably not what we want to do. We want to do it based on distance from camera, I think. T is screen space. So yeah. But we want to do it on depth difference, I think. No. We want to do it on ray depth VS. So the further away from the camera we are, the more we want to rely on this one. So not T, not T. We have ray max distance 100,000. is. It's way too thick. It's not too important, I don't think. Oh yeah, I want to fix the distance here. We wanted to base it on ray max distance. We can do ray max distance, and we can do let's see here. No. Let's do it on. Yeah, if we do it like this, we're gonna have to do a very big value, but that's okay. So T here, and we break, but we don't want to use T here. So intersection threshold, let's do float T intersection threshold. Inverse lerp between 0 and projection params Z. So that's our far clip plane. That's at 1000. And here we do ray depth VS. So if the ray in view space is 1000 units away from the camera, we do this thickness. If it's 0, we do this, and then we interpolate between. Fuck it, let's do saturate, even though we should not be having this problem. So we're gonna see that this one is important, or this one controls a lot. This one doesn't really do anything. We can go pretty high here. Oh, we actually see already here. Okay, that's interesting. That's very interesting. So we have to find. I would probably be okay with this. So instead of going, this is if we have the same thickness everywhere, and then we can go 1 here when we're a little bit further away from the camera. Changes very little here, but quite a lot here. 1, 2, 3, 4, 5, 6, 8. Ah. Are we getting... We're getting pretty high pretty early on here. Linear interpolation might not be the smartest one here, the smartest decision. 0.5 is quite nice though. 0.5. If we improve step length, okay. Before we do too much with this, we're gonna leave this one at 0.1 maybe. It's probably best to do the second iteration as well, because that one might remove some artifacts as well. But before I do that, I also want to do I want to figure out how I want to handle if we go off screen. If we go straight up, we want to get the skybox. If we go one sec, shouldn't we be getting if we do 10 1 10, or if we do let's do 1 1. Oh fuck, that's the wrong sphere. This one. That's fucking rough as fuck. I think this, by doing a second iteration, I think we're going to fix this banding issue as well. That's Miss Blue. What's up, what's up? We're probably going to fix this banding as well. Yeah, I reckon we should just do it. But then again, Yeah, we can fix this. We can fix this. I don't care about fill color for now. So we're gonna do this. We still want these. Smallest depth different point SS. Yeah, and we're still gonna have step. Yes. So the point. So when we get to, actually, let's comment this out. Oops. When we get to here, we're gonna do a second loop, and we're gonna check fuck, is this stupid? Yeah, I think we're gonna do a second step through, and we're gonna do it using this one and this one. So once again, it's this one. So we get this point with the step. We get this point as well. We get this point as well, and then we take halfway here, halfway here, and then we compare which one of these two are closer. If none of them are closer than this one, I wonder if we should just skip it. But we take the one that is closest, so maybe we get this one. So then we have these 2 points. Or we have these 3 now, so then we check this one and this one. Or actually, that's not how we want to do it. We compare which one is closest of these two. If we get this one, then we have... yeah, then we have these points. So then we check this and this. If this one is closest, then we get... how do we want to do it? We always want to compare 2 middle points to each other. So if this one is closest, then we should take this one and this one. Yo, what's up, Yuri? I don't know about King of Render features, but thank you. We always want to have 3 points. We want to take the 2 middle points. So if this one is closest, yeah, then we take this one, and this one. And then we interpolate here and here. If this one is closest, we take this point, and this point. Interpolate here and here. If this one is closest, and we do that over and over and over. We can exit early for some case, but we're probably gonna do this, I don't know, 5 times. Nah. We want to get down to, so it depends on our step length. I think. Because initially, if we have a step length of 5, this one is going to be at most 5 pixels away. So this one is at most 2.5 pixels away. So as soon as we get down to a step being less than 1, then we throw it away, basically. Yo, what's up, Fabic? Great to see you streaming, Robin. Thank you, appreciate it. It feels good to be back, and I think we have done some very good progress today as well. And great to see you too. Hope you had a productive night. Okay, so let's see if we can get this banding under control, because basically, if I understand it correctly, or if, yeah, pretty rough banding, but for these black ones here, I wonder why we get this banding. For the black pixels in here, we're gonna take this one, the next point, the previous point, and we're gonna search for an intersection that is okay with our thickness, basically. And we can see here that thickness based on distance pretty much solves, it helps solve that problem, so we might be able to rely on that one for lesser hardware, maybe. Yes, sir, as usual. Nice to hear. I also want to see later on what I can do about this one. I wonder if we can just, I think instead of having black here, I think we could smudge it. So we do, when we go out of bounds, let's see here, bam, bam. So when we end up here, we just take this color and fill it in here. So you're gonna get some, I think we would rather do that as opposed to having this. Great progress, by the way. Thank you, appreciate it. Yeah, it feels good being not as sick and to finally understand what's going on in a screen space reflection solution like this. But okay, let's see. So if we end up here, we want to have float 2. Yeah, let's do float 2. And we're gonna do I would want to name this point A in screen space, but yeah, just gonna call it point A, and it's gonna be equal to smallest depth different point SSXY minus step, and we're gonna have float 2 point middle. That's just gonna be smallest different point ss.xy and point B. So, yeah, once again, we don't want to do this. We want to do this. Never mind. So, in this case, this is point middle, this is point A, this is point B. And then we want to do, we're going to do int safe stop is equal to 0, int max is equal to, fuck it, let's do 20 first. We'll do while safe stop is less than safe stop max. Safe stop increment. Okay. So we're gonna do float 2 point middle A. This is going to be quite costly, I think. Does it matter in what order we do it? 0.5. Don't think so. For both of these, we want to do this and that. We might be better off here with calculating adding a function, but we want to calculate this. Do we care about this? Maybe this. Fuck, we want to calculate this one. Depth difference. Oh, fuck, I screwed up here previously as well. We want to use this one. What the hell? I just want to try this real quick. T intersection threshold. I think we can afford a lot bigger. I think we can afford, we clean up things that are far away way better without destroying things that are close. But it's still not too good, I think. Oh well. Let's see if we can fix this. So I'm thinking about, oh. We're probably gonna put this, this. We use this one here though. I think I want to put as much of this into its separate function as I can. It's pretty much only depth difference. It's depth difference and intersection threshold we care about. It's mostly depth difference. This one needs this, which needs this. It should, even though this one is going to be extremely heavy to calculate, I think this is what we want to do. Actually, this current approach, what you could do as well is you could have this as a second step for points that are close to the difference. So this one could be, this one could be I don't know which. You could either do it so that this one is big here, and then we do this for points where this is true, so we do this for a way smaller intersection threshold. Or we can do it this way, so we do step here is big, and then we do this for points that don't find. I don't know. But anyway, let's start by doing wonder if we want to return a bool here, maybe. And then with a out parameter that is depth difference. Because if this happens, we want to return false. If this happens, we want to return false. Pretty much. or calculate depth difference to ray depth, scene depth, okay, to scene depth. -1 I think is gonna be the default. So what we want to do in here is this one we're going to calculate outside. We want to check this. I wonder how we want to check it. If return false, because we don't, okay, calculate depth difference to scene. This is for a point that doesn't have a depth difference to scene. And then we calculate this one. Oh, then we need to send in start point and end point. And if we do that, we might as well so point SS point start SS point end SS. Maybe does this make sense? So we calculated T, we want to check this as well. So if T is bigger than 1, i.e. we have walked along the full line, then we want to return false as well. Then we calculate the ray depth, we read the scene depth. But then we have this problem still, like we need to use this one out here. For now I'm thinking about doing this, probably gonna I think we can do that for now. So ray depth vs, we do interpolation with projection in mind between ray start point depth, ray end point depth. And then we read here ray current point SS. So this is just, fuck, we need these as well, that's true. There's a lot of things we need to send in here. Honestly, I think we're gonna do this way nicer. We're gonna create a custom ray struct, and we're gonna add some functions to that ray struct. So a ray struct will be defined by its start point and end point in view space, its start point and end point in screen space, and then it will have a couple of methods for calculating things we might need later on. I think, yeah, that's probably what we're gonna do. Unfortunately, that's gonna have to wait until tomorrow because I gotta run. But I think I'm having high hopes for this second. Yeah, we can probably make this into a method of the struct later on as well. It's gonna be very nice. But I'm having high hopes for this. We're gonna remove a lot of banding, I think, in one way or another, and just improve the overall reflection. And then we can see what we can do about the other artifacts that are not as important as the banding one. But yeah, I gotta run. The DAC, thank you so much for the follow, appreciate it. So, thank you so much for watching, everybody. Hopefully I will see you tomorrow, and have a great rest of the day. Peace.